So, have you ever noticed that the inside and outside of a tire both rotate together, but the outside looks like it's going further? So, you may think, like, how is that possible? Well, as Brother Richie would say, there's the key. So, a wheel is a rigid body, which that just means like it's a physical object where the distance between any 2 points within it remains constant, regardless of like any external forces acting on it. So, like every point rotates through the same angle in the same amount of time. So I'll try to explain it, but just keep that in the back of your head. So if we want to show like the math for distance, right? So we can imagine this is a wheel. And so we'll say this is the outside of the rim right there. We'll say that this is the outside of the tire, right? So the formula for arc length, right, we'll just call it S, is equal to the radius of whatever we're looking at multiplied by the angle of what we're looking at. So, if you think of a circle or a tire, right, you can start at this point right here, go all the way around, and that's 360 degrees, right? Or, if you're thinking in terms of radians, that's what, 2 pi? So we'll just call a full rotation, right? We'll just say over one turn. We'll just call that 2 pi. So if we want to take the inside, right, so we'll call this S inner, play on word there, but we'll call that, 2 pi times the radius of the inner, whatever that may be. Then if we want to look at the outside, it's similar. And we'll just say it's 2 pi times the radius of the outer, whatever that may be. And we can give it an example. So let's just say the inside is 0.25 meters, and we'll say the outside is 0.4 meters. So we can go 2 pi, 0.4 meters. Similarly, we can go 2 pi, 0.4, and I messed that up, 0.25, right? And so that's around 1.571-ish. And this one's around 2.513. So if we want to take like the ratio, and I was explaining earlier, it's just a ratio. So we just take the 2.513 divided by 1.571. And that's a ratio of roughly 1.6, just to kind of show you that part of it. So this, it shows that there's a 1.6 ratio between the two, and so the outside actually has to travel further by a factor of 1.6 further than the inside. Cool, right? You may not think it's cool, but I think it's cool. But anyways, so getting back to same rotational speed for all points, right? So a wheel is a rigid body, so every point spins through the same angle in the same time, and this is called angular speed, right? Angular speed, and we're going to call that omega, just a W. To measured in radians per second. So there's that. Now there's something called tangential speed, which depends just purely upon the radius. And so we'll just call that V. And that's the angular velocity times the radius, where V is the tangential speed, how fast the point is moving through space. And radius is just the distance from the center. So if we want to take, so like, because the radius is bigger for the outer tread than the inner rim, right? The outer tread has a larger V, if you want to say that, even though both points spin at the same angular speed, right? So if we want to take an example here, so let's say that the angular speed is 10 radians per second, something like that. So the inner point, right, was 0.25 meters. So if we go V inner, right, is equal to that W 10 times the 0.25. My handwriting's getting sloppy now. So that's going to be 2.5 meters per second. Well, if we do the V of the outer, that's 10 times the 0.4, and that's going to be 4 meters per second, right? So we obviously can see from this right here that, the outer has to spin faster. And so the takeaway is the same rotation rate, if it's a bigger radius, it's going to have to move faster linearly. That's just how the math works. So there you go, Josh.